Right now, the concrete driveway outside your house is secretly disrupting a planetary engine that took millions of years to build.
Yeah, which is a wild thing to wrap your head around.
Right. I mean, we usually look out our windows after a rainstorm and we see like a puddle forming on the street and we just think of it as a temporary inconvenience, a brief anomaly.
Exactly, just something you have
Mm.
to step over to get to your car.
Yeah, but today we are mapping the hidden plumbing of the Earth. Welcome to today's deep dive, everyone. I'm your host, and joining me as always is our resident expert to help unpack this.
Hi, everyone. Glad to be here. And, to truly understand how this world sustains life, you really have to look past the surface level weather.
Right, the stuff we see on the news.
Exactly. We need to trace how water physically moves, how it constantly changes density, and how it acts as the vital connective tissue between that single puddle in your backyard and the absolute deepest, most inaccessible ocean trenches.
And that is our mission today. We are taking you on a descent into the intricate mechanics of the Earth's hydrosphere.
It's a fascinating journey.
It really is. We'll examine the gravity-driven engines and the massive thermal batteries that keep everything running, and we're going to look really closely at what physically happens when human infrastructure, alters the baseline mechanics of those ancient systems.
Right, and it is so tempting to start a conversation about the hydrosphere by just, well, looking outward at the ocean.
Sure, I mean, it covers the vast majority of the planet.
Yeah, but the mechanics actually begin right beneath our feet. They're governed by the local topography of river basins.
Wait, so even if you're completely landlocked?
Oh, absolutely. Even if you are sitting hundreds of miles from the nearest coastline, you live inside a river basin.
Wow, okay. So every inch of land on Earth is essentially like a slanted catchment area.
Precisely. If you look at the topography of a place like North Carolina, for instance, every single drop of rain that hits the ground is immediately entering an interconnected gravity-driven funnel.
Just constantly moving downhill.
Yeah, it hits the soil, it drains into local creeks, it seeps downward into subterranean springs and aquifers, and then merges into these wide estuaries before finally being pulled out into the Atlantic.
So gravity is really the dominant physical force here. It dictates the speed and the trajectory of all that water.
It is, and gravity doesn't just move the water, right? It kind of weaponizes it.
Weaponizes it. How
The-
so?
Well, as that water gets dragged downhill, the sheer physical friction causes massive weathering and erosion. I mean, it literally carves out deep valleys, flattens mountains, and hollows out massive underground limestone formations over millennia.
That's incredible. But, we always hear about the sun powering the water cycle, right? By evaporating moisture back up into the atmosphere.
Right, evaporation, transpiration, condensation,
Right.
precipitation.
All of that. But what is physically happening underground? Like what pulls all this water through the actual subterranean rock?
So that really comes down to the mechanics of aquifers, which operate primarily through soil friction and pressure. We have two main types, unconfined aquifers and confined aquifers.
Okay, let's unpack this.
Sure. So the unconfined aquifer is basically your local water table. Because it sits relatively close to the surface, it's highly responsive to the immediate physical environment above it.
Okay, if we think about how these mechanically function, an unconfined aquifer is almost like a thick, highly porous sponge, right? Just sitting open on a kitchen counter.
That's a really good way to look at it.
Because whatever hits the surface above it, whether that's fresh rainwater or, synthetic lawn fertilizer or spilled motor oil, it's going to percolate directly down into that sponge.
Exactly. It is completely vulnerable to surface events. But a confined aquifer operates differently.
How so?
Well, going back to your analogy, it's that same sponge, but imagine vacuum sealed inside a thick plastic bag, like a Ziploc, trapped under a dense layer of impermeable clay or rock.
Oh, I see. So it's totally protected.
Right. The confined aquifer is under immense geological pressure and operates on a timeline of centuries or even millennia. It is completely isolated from immediate surface weather.
But the unconfined one isn't.
No, not at all. The unconfined aquifer relies entirely on a slow, continuous recharge from the surface. When natural land is highly permeable, water filters down at this glacial pace. And the friction of the soil layers actually strips impurities from the water as it descends.
So it naturally filters it before it recharges that subterranean sponge.
Exactly.
But this is exactly where the driveway comes in, isn't it?
Yep. Here's where we ruin it.
Right, because human infrastructure fundamentally destroys that soil friction. When we build subdivisions, lay down road networks, or pave massive concrete parking lots,
We are laying down square miles of impermeable surface.
we're essentially throwing a giant plastic tarp over that unconfined sponge.
What's fascinating here is how the physics of the watershed shift dramatically in that scenario.
Yeah.
Instead of gravity pulling water slowly, vertically through a porous geological filter,
It just hits a wall.
it hits the asphalt, it pulls, and it accelerates horizontally. It immediately becomes high-velocity surface runoff.
Okay, so if human construction is altering our water tables like that, how exactly does building a new subdivision impact that underground sponge? I mean, long term.
Well, the local water table beneath that subdivision drops because it has literally been mechanically starved of its recharge mechanism.
Wait, really? So if you rely on a local well for your house?
That well runs dry. And not because it didn't rain, but because the rain was physically prevented from soaking into the ground.
Oh, wow. That is wild.
And it gets worse. Because the water is now rushing horizontally across the asphalt, it picks up kinetic energy and carrying capacity.
Right, it's moving fast.
Super fast. So it sweeps up heavy metals from brake pads, oils from roadways, agricultural runoff, and it fast-tracks all of it downstream.
So by sealing the surface, we are just bypassing the slow frictional filtration system entirely.
Exactly. We dump the burden entirely onto the next phase of the planetary plumbing.
All right, okay. So that high-velocity, highly polluted runoff gets dragged downhill by gravity until it collides with the coastal transition zone, the estuaries.
Yes. This is where the rushing freshwater from the continent physically crashes into the dense saltwater of the open ocean.
The brackish water zone.
Exactly. And estuaries function as the ultimate ecological buffer. They're this intricate series of biological and physical speed bumps.
Speed bumps.
Yeah, think about it. When a high-velocity river carrying all that suspended sediment and urban runoff hits the wide, shallow expanse of an estuary, the physical dynamics of the water change in an instant.
Right, because it's a sudden and massive loss of momentum.
Exactly.
When water is rushing down a narrow, confined river channel, it maintains the kinetic energy necessary to carry heavy sediment and particulate matter.
Yeah.
But the moment it spreads out into the wide, shallow estuary basin,
It loses all that energy.
it drastically slows down. And those heavy particles, they simply drop out of suspension and fall to the bottom.
And that physical dropping of sediment is the primary stage of filtration. But the secondary stage is biological.
The plants, right.
Yeah, the dense networks of marsh grasses and wetlands in the estuary act as active biological scrubbers.
Wow.
Their deep root systems absorb excess nitrogen and phosphorus. They trap heavy metals and pollutants in the mud. They're functionally purifying the water before it's permitted to enter the delicate marine environment.
I mean, estuaries are essentially the VIP bouncers, or maybe the kidneys of the earth.
I love that, the bouncers of the ocean.
Yeah, they are actively processing the toxicity of the upland runoff. But I gotta push back with a question here.
Sure, go for it.
If these estuaries are constantly acting as filters for all the pollution washing down from human activities in the river basins, where does all that bad stuff actually go?
It's a great question.
Because a biological kidney can only process so much toxicity before it undergoes renal failure. Is there a limit to how much these ecosystems can absorb before the filter breaks?
Yes, there is absolutely a limit. It accumulates, and it hits a carrying capacity. The heavy metals settle semi-permanently into the mud. The excess agricultural nutrients get absorbed by the plant life.
Which then gets eaten by the local animals.
Exactly, moving the toxicity right up the food web. And this connects back to the core framework principle. You cannot isolate an ecological impact. Changes in one part of the cycle inevitably affect the others.
So changes in the river basin forcefully manifest in the estuary.
Exactly. If an estuary exceeds its carrying capacity, say it receives an influx of nitrogen from fertilizer runoff, so massive, it triggers a hyper-aggressive algae bloom.
Oh, I've heard of those. The
Yeah.
bread tides and things like that.
Right. That bloom consumes all the dissolved oxygen in the water, suffocating the plant life and the fish. The filtration system completely collapses.
So the biological speed bumps just die off?
Yep. And without that living buffer, the raw, unfiltered toxicity from the river basin pours straight into the open ocean.
Which drastically alters the chemistry of the coastal water.
Exactly. The functional health of the estuary strictly dictates the baseline health of the ocean it feeds into.
Okay, so let's follow that water. It clears the estuarine kidneys, hopefully, and enters the open sea. But it doesn't just diffuse into the deep and sit still, right?
No, not at all. It gets caught up in a massive planetary-scale transit system known as thermohaline circulation. the global ocean conveyor belt.
Here's where it gets really interesting. This is a global current driven fundamentally by water density, right? Not just surface winds.
Right. Thermo refers to temperature, and haline refers to salinity or saltiness.
I think it's helpful to visualize this not just as a hidden river in the ocean, but also like the ocean is basically a planetary HVAC system combined with a global grocery delivery
Oh,
service.
that's a perfect way to describe it.
Like if you look at a hot water heating system in an old house, the boiler in the basement heats the water, and a pump pushes that hot water through pipes to the freezing rooms upstairs.
Right.
And the pipes radiate heat into those cold rooms before the water cools and sinks back down to the boiler to start over. The ocean is basically doing this on a global scale.
Exactly. The equator is the planetary boiler. It absorbs massive amounts of direct solar radiation, and the ocean currents act as the pipes, pushing that warm water toward the poles.
And the mechanics work because water has like an immense specific heat capacity, right?
Yes, it can absorb, store, and transport vast quantities of solar energy without dramatically changing its own temperature or boiling away.
Which land masses definitely cannot do.
No, land masses only absorb heat at a very shallow surface level, and then they radiate it away quickly at night.
Right.
But as that massive volume of warm equatorial water travels toward regions like northern Europe, it slowly releases its stored thermal energy into the atmosphere.
Which is exactly why coastal cities have significantly milder climates than inland areas at the exact same latitude.
Precisely. The ocean is literally a thermal battery regulating the atmospheric temperature of the coastline.
Okay, it makes sense that the sun is heating the water at the equator. But what is the pump? If the sun is constantly warming the surface of the ocean, how does the system generate enough physical force to push millions of cubic meters of water thousands of miles around the globe?
Well, the pump for this entire planetary radiator isn't at the equator at all.
Oh, it isn't.
Nope. It's located at the poles, and it runs on extreme cold and extreme salt.
Okay, how does that work?
When ocean water reaches the Arctic or the Antarctic, it undergoes a radical physical state change. As the surface water freezes into sea ice, the freshwater molecules lock into the solid ice structure, but they physically expel the salt.
Which leaves the surrounding unfrozen liquid water heavily concentrated with salt.
Exactly. And water that is both near freezing and hyperconcentrated with salt is exceptionally dense.
Really heavy.
So heavy that it plummets thousands of meters straight down to the abyssal ocean floor.
Oh, wow. So that massive vertical drop creates a physical void at the surface.
A huge void. A void that must be filled. When millions of gallons of dense water drop to the seafloor, surface water from lower latitudes is physically pulled northward to fill the vacuum.
That makes perfect sense. So this continuous aggressive sinking at the poles is the primary mechanical pump dragging the warm water up from the equator.
Yes, driving the entire global loop.
And while that deep density pump is driving the conveyor belt from below, the surface currents are also being, violently manipulated by the atmosphere.
Right, the winds.
The winds are pushing the surface water, but they don't push it in straight lines because of the Coriolis effect.
Right. You have to consider the geometry of a spinning sphere. The Earth is wider at the equator than it is at the poles.
Right.
Because of this, land masses at the equator have to physically rotate much faster through space to complete a 24-hour rotation than land masses near the poles do.
It's exactly like a spinning vinyl record.
Yes, exactly.
A point on the outside edge has to cover far more distance, traveling much faster, than a point near the center label to complete a single rotation in the same amount of time.
And that differential in rotational speed causes moving objects, like global wind currents, moving north or south, to curve relative to the surface.
Bending the winds.
Right. In the northern hemisphere, winds are deflected to the right. In the southern hemisphere, they are deflected to the left.
And this Coriolis deflection bends the surface winds, which in turn physically pushes the surface ocean currents into these massive, rotating gyres that help distribute that equatorial heat.
Along with greenhouse gases in the atmosphere absorbing and retaining that energy, it regulates the Earth's average surface temperature.
Okay, but this raises a terrifying mechanical scenario.
Well, here we go.
If this entire global engine runs on temperature and salt, what happens to this conveyor belt if the ice caps melt, dumping millions of gallons of fresh, unsalty water into those polar regions?
If we connect this to the bigger picture, the implications are massive. You immediately dilute the salinity.
Right.
If you flood the polar regions with fresh meltwater, the surface ocean water is no longer salty enough or cold enough to achieve the density required to sink.
So the heavy water literally just starts dropping.
Yes, and if the water doesn't drop to the ocean floor, the vacuum isn't created at the surface.
And if the vacuum disappears,
The warm water from the equator is no longer pulled northward. The massive global conveyor belt just stalls.
that is terrifying.
If thermoheating circulation slows down, the planetary radiator shuts off. The equatorial regions would trap their solar heat and become brutally, unlivably hot.
While regions that strictly rely on the ocean's thermal delivery, like London or Scandinavia, would see their average temperatures just plummet.
Exactly. And not to mention, you called it a global grocery delivery service earlier.
Right, because it moves dissolved oxygen from the surface down to the deep and sweeps nitrogen and crucial minerals across the planet.
So if the current stalls, the delivery of those vital chemical resources to marine ecosystems simply stops.
The entire climate regulatory system and the biological survival of the oceans hinges on that precise mathematical balance of salt and temperature at the poles.
It really does. Which brings us to the vertical plumbing of the ocean.
Yes, because we've mapped how water moves horizontally across the globe, from the river basins out to the poles. But the true lifeblood of the ocean and the planet relies on extreme vertical movement into the deep, dark ocean zones.
Right, because the ocean is vertically stratified by light penetration. The surface zone is where the photosynthesis happens. But as you descend into the bathypelagic and abyssopelagic zones, the physical environment shifts drastically.
It gets weird down there.
Very. It is pitch black, near freezing, and under crushing atmospheric pressure.
So what does this all mean? I mean, we typically think of the deep, dark seafloor as a barren wasteland because there's no sunlight. If there is no light for photosynthesis, there shouldn't be a robust food web.
You'd think so, but the mechanics of the deep ocean act as a massive, pressurized nutrient vault.
Okay, but how exactly does upwelling bring the groceries from the dark depths all the way to the surface? How does life exist down there?
This raises an important question. Let's examine the vault first.
Okay.
Over centuries, organic matter from the surface dead marine life, decaying plant matter, microscopic shells, it all slowly sinks to the ocean floor.
Just drifting down into the dark.
Right. And because the deep ocean is so cold and under such immense physical pressure, the water down there is capable of holding massive, concentrated amounts of dissolved gases and nutrients. It just sits there, trapped in the cold, dense layers at the bottom of the world.
Until the surface winds trigger a mechanical process called upwelling.
Exactly. And upwelling is a pretty violent physical displacement.
So?
When strong, consistent surface winds blow parallel to a coastline, the Coriolis effect we mentioned earlier deflects that surface water away from the shore. The wind physically sweeps the warm, sunlit coastal water out to sea.
Creating yet another massive vacuum.
An enormous one. And nature abhors a vacuum. To fill the physical void left by the departing surface water, the cold, heavy, nutrient-dense water from the deep ocean vault is sucked violently vertically upward.
Oh, wow. So it pulls the centuries-old fertilizer straight to the surface?
Yeah, when those deep, mineral-rich waters hit the photic zone, the sunlit layer at the surface, it acts as an explosive biological catalyst.
Because now there's light and nutrients.
Exactly. It triggers massive, rapid blooms of phytoplankton. These microscopic organisms form the absolute base of the marine food web.
So they feed the zooplankton.
Which feed the small schooling fish, which attract the apex predators and the seabirds. Regions with strong, consistent upwelling are turbulent, but they contain the highest concentrations of marine biodiversity on the entire planet.
That is amazing. But what physically happens if upwelling fails? Say the wind patterns shift due to atmospheric changes, and that surface water doesn't get pushed offshore.
Well, we actually witnessed this catastrophic mechanical failure during El Niño events.
Oh, right.
The prevailing winds weaken, the warm surface water stays parked against the coast, and the deep, cold water remains permanently trapped below.
Wow. So without that upward delivery of nutrients, the phytoplankton simply do not bloom.
Right. The entire food web starves from the bottom up. The fish migrate away or die, and the coastal ecosystem, right up to the commercial fishing industries on land, experiences a sudden and total economic and biological collapse.
It perfectly illustrates how fragile biological survival is when it relies entirely on fluid mechanics.
It really does.
But even in the total absence of upwelling, and the deepest, darkest parts of the seafloor where the vault is prominently sealed, life has actually found a biological workaround. We have to talk about hydrothermal vents.
Oh, these are fascinating. These are deep fissures in the Earth's crust, usually situated along volatile tectonic boundaries.
Right.
Superheated water, heavily laden with dissolved, toxic minerals from the Earth's mantle, erupts continuously into the freezing deep ocean.
So it operates much like an underwater geyser, but instead of just heat, it's pumping out a concentrated soup of, like, hydrogen sulfide.
Exactly. And rather than relying on sunlight and photosynthesis, highly specialized bacteria living around these vents utilize a process called chemosynthesis.
Making energy from chemicals instead of light.
Right. They chemically convert the toxic minerals erupting from the vent directly into cellular energy. Entire complex ecosystems, giant tube worms, blind shrimp, unique species of crabs, they thrive in the pitch black.
Completely disconnected from the solar energy that powers the rest of the planet.
It is entirely disconnected.
It's literally a completely self-sustaining alien world, operating on a different physical paradigm, hiding at the bottom of our own ocean.
It really proves that the deep ocean isn't a wasteland at all. It is the hidden foundational engine of the global ecosystem.
Right.
The pressure and temperature governing dissolved gases down there ultimately dictate the survival of life forms not just in the water, but on land as well.
Yeah.
I mean, the very oxygen you are breathing right now is heavily dependent on the phytoplankton blooms in the ocean.
Which are fed by the upward velocity of nutrients from the deep.
Exactly.
Let's take a step back and look at the whole board here. We started in your driveway, watching a drop of water hit impermeable asphalt, bypassing the slow, frictional geological filtration of the aquifer and rushing at high velocity into the estuaries.
Right.
We watched those coastal biological speed bumps try to scrub the heavy metals before releasing the water into the global conveyor belt.
A conveyor belt heavily powered by the physical density of cold, hypersalty water sinking into the abyss at the pole.
Pulling equatorial heat across the globe, while surface winds, bent by the rotational geometry of the Earth, churn the surface into gyres.
And finally, we plunged into the deep ocean vaults, holding centuries of dead organic matter under crushing pressure.
Just waiting for a localized shift in the wind to pull it vertically to the surface and trigger massive explosions of biological life. It is an incredibly complex, violently interconnected engine.
It really is.
Every time you turn on a tap or dig a foundation or feel a mild coastal breeze, you are actively participating in and feeling the ambient hum of this massive planetary plumbing system.
And because the system relies on such precise, delicate physical parameters, the permeability of local soil, the exact density of polar salt water, the specific heat capacity of the ocean altering any single baseline variable reverberates aggressively through the entire structure.
Which leaves us with a critical, somewhat haunting thought to end on today.
Yeah, it's a sobering one.
Because oceanic and atmospheric flow patterns are incredibly complex, right? They're constantly interacting with shifting latitudes, altitudes, and local topography. And because of that, the resulting weather can only be predicted probabilistically.
Right. Meteorologists look at the historical parameters and calculate the odds of what the fluid mechanics will do next.
But human activities are aggressively and simultaneously altering those foundational baseline parameters.
Exactly. We are replacing naturally porous land with thousands of miles of impermeable concrete. We are shifting the density of the atmospheric greenhouse gases that govern ocean temperatures and currents.
We are actively dumping millions of gallons of fresh meltwater into the salty polar engine that drives the ocean currents.
We are rewriting the physics of the hydrosphere in real time.
We aren't just changing the climate. We might be pushing this delicately balanced, probabilistically predicted system into a state of total chaotic unpredictability. The historical odds no longer apply because the engine itself has been mechanically modified.
It's uncharted territory.
It is. So the next time you look out your window at a puddle forming on the street, here's something to mull over. What happens to a human society that can no longer mathematically rely on the predictability of its own weather?
That is the defining question of our era. And it's the exact reason we must understand the mechanics beneath our feet.
Thank you for joining us on this deep dive into the hydrosphere. Keep learning, keep questioning, and we'll catch you next time.